Hi, this is Sleeper. Welcome back to my channel. We are continuing the Web Security Academy read-through with Path Traversal. In this section, we explain what Path Traversal is, how to carry out Path Traversal attacks and circumvent common obstacles, and how to prevent Path Traversal vulnerabilities. What is Path Traversal? Path traversal is also known as directory traversal. These vulnerabilities enable an attacker to read arbitrary files on the server that is running an application. This might include application code and data, credentials for backend systems, and sensitive operating system files. In some cases, an attacker might be able to write to arbitrary files on the server, allowing them to modify application data or behavior, and ultimately take full control of the server. Reading arbitrary files via path traversal. Imagine a shopping application that displays images of items for sale. This might load an image using the following HTML. Image source equals / load image, file name equals 218.ping. The load image URL takes a file name parameter and returns the contents of the specified file. The image files are stored on a disk in the location /var /images. To return an image, the application appends the requested file name to this base directory and uses a file system API to read the contents of the file. In other words, the application reads from the following file path: var images 218.ping. This application implements no defenses against path traversal attacks. As a result, an attacker can request the following URL to retrieve the etc password file from the server's file system. So insecurewebsite.com /load image file name equals // etc password. This causes the application to read from the following file path: var images images // etc password. The sequence / is valid within a file path and means to step up one level in the directory structure. The 3 consecutive / sequences step up from the var images to the file system root, and so the file that is actually read is etc password. On Unix-based operating systems, this is a standard file containing details of the users that are registered on the server, but an attacker could retrieve other arbitrary files using the same technique. On Windows, both // and / are valid directory traversal sequences. The following is an example of an equivalent attack against a Windows-based server. So it uses // instead, windows /win.ini. Common obstacles to exploiting path traversal vulnerabilities. Many applications that place user input into file paths implement defenses against path traversal attacks. These can often be bypassed. If an application strips or blocks directory traversal sequences from the user-supplied file name, it might be possible to bypass the defense using a variety of techniques. You might be able to use an absolute path from the file system root, such as file name equals etc password, to directly reference a file without using any traversal sequences. You might be able to use nested traversal sequences, such as 4 dots and 2 backslashes, or 4 dots //, These revert to simple traversal sequences when the inner sequence is stripped. In some contexts, such as in a URL path or the file name parameter of a multi-part/form data request, web servers may strip any directory traversal sequences before passing your input to the application. You can sometimes bypass this kind of sanitization by URL encoding, or even double URL encoding, the ... characters. This results in the following: the first one being URL encoded, the second being double URL encoded, respectively. Various non-standard encodings, such as the following, may also work. For Burp Suite professional users, Burp Intruder provides the predefined payload list fuzzing-path traversal. This contains some encoding path traversal sequences that you can try. An application may require the user-supplied file name to start with the expected base folder, such as var www images. In this case, it might be possible to include the required base folder followed by suitable traversal sequences. For example, file name equals var www images ... // password. An application may require the user-supplied file name to end with an expected file extension, such as .png. In this case, it might be possible to use a null byte to effectively terminate the file path before the required extension. For example, file name equals ... // password null byte .png. How to prevent a path traversal attack. The most effective way to prevent path traversal vulnerabilities is to avoid passing user-supplied input to file system APIs altogether. Many application functions that do this can be rewritten to deliver the same behavior in a safer way. If you can't avoid passing user-supplied input to file system APIs, we recommend using 2 layers of defense to prevent attacks. 1. Validate the user input before processing it. Ideally, compare the user input with a whitelist of permitted values. If that isn't possible, verify the input contains only permitted content, such as alphanumeric characters only. And 2. After validating the supplied input, append the input to the base directory and use a platform file system API to canonicalize the path. Verify that the canonicalized path starts with the expected base directory. Below is an example of some simple Java code to validate the canonical path of a file based on user input. Once again, my name is Sleeper, and that's a wrap. Until next time.